Soil investigation. At Foressa Mountain View, Balamban Cebu, 2 holes. Soil testing for construction projects. Before a construction project can proceed, the project's soil is tested to ensure that it can support the load. There are several different soil testing methods, but which method you choose depends on the soil's properties. In this blog, we'll look at 5 soil testing methods used for construction projects. Soil testing methods for construction projects. 1. Moisture content test. Measuring soil moisture content can be done in several different ways, such as the alcohol method, the radiation method, the sand bath method, the pycnometer method, the torsion balance method, the calcium carbide, and the oven drying method. The most popular moisture content testing method is the oven drying method, in which the sample soil is weighed, dried at a temperature of 110 degrees, and then weighed again to measure the difference. Several types of moisture content tests are commonly used in construction to determine the water content in soil. These tests help ensure proper compaction, foundation stability, and overall construction quality. Here are some of the key types of moisture content tests for construction. Gravimetric method, oven drying method. This is one of the most accurate and widely used methods. It involves collecting a soil sample, weighing it when wet, drying it in an oven at a specific temperature, typically around 110 degrees Celsius, and then reweighing it to calculate moisture content based on the weight difference. Calcium carbide method. In this method, soil samples are mixed with calcium carbide, which reacts with water to produce acetylene gas. The amount of gas produced is proportional to the moisture content in the soil. Torsion balance method. The torsion balance method measures the weight loss of a soil sample during drying. It is suitable for both field and laboratory applications. Pycnometer method. This method involves using a calibrated glass container, pycnometer, to measure soil moisture content. The sample is saturated with water, and the change in volume is used to calculate moisture content. It is often used in laboratory settings due to its precision. The moisture content test provides critical information about the soil's water content, which is essential for various engineering calculations and the design of foundations, slopes, and retaining structures. 2. Specific gravity test. The specific gravity of any material is measured by the ratio of the water's density to the density of the substance. The choice of method depends on factors such as the nature of the material being tested and the precision required. Gas jar method. This method involves immersing a sample of the material in a gas jar filled with water and measuring the volume of water displaced. It is commonly used for coarse-grained soils and aggregates. Measuring flask method. In this method, a known volume of the material is placed in a measuring flask, and its weight is measured. The flask is then filled with water, and the weight is measured again. The difference in weights allows for the calculation of specific gravity, making it suitable for materials with irregular shapes. Density bottle method. This method utilizes a specially designed density bottle with a precise volume. The substance is introduced into the bottle, and the bottle is weighed both empty and filled with water. This method is often preferred for fine-grained materials like soils and powders. These various methods offer flexibility in determining specific gravity, ensuring that accurate measurements can be obtained for a wide range of construction materials. The specific method chosen should align with the properties and characteristics of the material under investigation. 3. Atterberg limits test. This type of test is used to measure the critical water content of fine-grained soil. 3 limits can measure the properties of a fine-grained soil. Shrinkage limit. A mathematical formula determines the water content that can fill the soil's voids. Plastic limit. The soil sample is mixed with water to make it plastic. The soil is then molded into a ball shape and rolled into 3 mm threads. If these threads cannot break, then the process is repeated with less water and a new soil sample. This continues until the thread eventually breaks. Liquid limit. A Casagrande's liquid limit device is used, which is made up of a cup with a device that rises and falls to measure the soil's liquid limit. 4. Dry density test. The dry density of soil is calculated by the weight of the soil particles in a particular sample. The dry density depends on the soil's specific gravity and the void ratio, which is then used to classify the soil into different density, loose, medium dense, or dense. This test is completed via 3 other methods: water displacement, core cutter, or sand replacement. Water displacement method. In the water displacement method, a known volume of soil is placed in a container of known volume, and the increase in water level is measured. The dry density is then determined using the weight of the soil and the change in water level, considering the specific gravity of water. Core cutter method. The core cutter method involves driving a cylindrical core cutter into the soil at a known depth and extracting a soil core. The weight and volume of the extracted core are measured, allowing for the calculation of dry density. Sand replacement method. In the sand replacement method, a hole is excavated in the ground, and the soil is removed and replaced with a known weight of sand. The volume of sand required to fill the hole is used to calculate the soil's volume, and by knowing the weight of the soil, the dry density can be determined. These methods provide different ways to assess the dry density of soil, and the choice of method depends on factors such as the soil type, project requirements, and equipment availability. 5. Proctor's compaction test. This test is used to find out the soil's compaction characteristics. First, the soil is air-dried, then divided into smaller samples and given between 3 and 5% water. These are then put into the Proctor compaction mold and hammered in, then taken out and dried to determine their water content and dry density. It's important to emphasize the significance of the test results. The results obtained from the Proctor compaction test are crucial in the construction industry. They provide valuable insights into how the soil will behave under the weight and pressure of a building or other structures. By determining the optimum moisture content and maximum dry density of the soil, engineers can make informed decisions about compaction during construction. This ensures that the soil is compacted to the right level, preventing settlement issues, and ensuring the stability and longevity of the constructed project. Moreover, the test results help in selecting appropriate construction materials and methods, making it an indispensable part of the soil testing process for construction projects. Are you looking for vibration monitoring services to assess the potential damage caused by your construction project? Contact us and maximize your project's productivity and profitability by supporting it with our geotechnical and geological experience. We are open from Monday to Saturday, located at JS Cabahug St, Sitio Basbas, Pagsabungan, Mandaue City. For more info, please contact us at 0908-67-75422, 099-567-09883, 099-514-17464, and tell number 3280626. Thank you for watching.